I've always liked using the concept of a taxi ride to help me remember the basic linear equation, y equals ax plus b, where a is the slope and b is the y-intercept. Everyone understands the concept of a taxi ride, and everyone knows that when you get in the taxi, they charge you a certain amount right away as soon as you're in there. It's not necessarily $4. I chose $4 because it's a round number and easy to use when I'm doing the math. But then once you're in the taxi, once the ride starts, they're charging you as time goes by and as the kilometers roll by. But wait, which is it? Is it that they're charging you a certain amount per minute, or are they charging you a certain amount per kilometer? The answer is it's both. The meter of the taxi is doing both of these things, although they're not necessarily using the math equations that I'm going to make in this problem. But what they're doing is they're taking into account the fact that sometimes there's no traffic and the taxi covers a number of kilometers and gets to the end of the ride very quickly. And if they were to charge you per kilometer, that's okay. But if they charge you per minute, they don't make as much money. And then there are times when there's a lot of traffic and the taxi could take quite a long time to get a pretty short distance. And when that happens, if they charge you per minute, that's okay. They make money. But if they charge you per kilometer, they didn't go very far. So they're not making very much money. So what they do is both beneficial to them and fair to you, the customer, because they take turns doing these two things. When there's a lot of traffic, you're being charged per minute. And when there's very little traffic, you're being charged per kilometer. To make this situation fit into an equation, I'm really doing the same thing on both sides because I chose the same y-intercept for both situations and I chose the same slope for both situations. And again, I'm choosing round numbers to make the math easy to look at. So y equals ax plus b means, in this case, y equals 2x plus 4. The plus 4 is the y-intercept, and it's the amount that they charge you when you get into the taxi. And the 2 is the slope, and it's the amount per minute that's charged. It's going to be multiplied by the number of minutes. The same thing happens over here, except the unit has changed. You still have dollars on your y-axis, but instead of having minutes on your x-axis, you're having kilometers on your x-axis. We still get y equals 2x plus 4 over here. When we graph this, 4 is the y-intercept. So we have the point 0,4. And the line has a positive slope because the slope is a positive number. And you get to see a little picture of your taxi ride. The same picture would happen over here with this one. The reason I like this example, and I like to talk about how it could be per minute or it could be per kilometer, is because when a student is just learning this, they find it confusing. And this is a simple situation that you can sort of memorize and think about whenever you're dealing with the y equals ax plus b linear situation. That helps you to remember, oh yeah, that money on the meter, that's my y-intercept, and the amount they're charging per kilometer or per minute is the slope. And when they give you a different situation, say in an exam that has nothing to do with a taxi ride, you're able to sort of figure out which number goes where in the equation more easily because you use this one as an example.